Hello friends and welcome to Geeks for Geeks. In this video, we are going to understand the program which constructs a special binary tree from given in-order traversal. First, let us take an example. The maximum element in given array must be root. The elements on left side of the maximum element are in the left subtree and the element on the right side are right subtree. Now, let us see the algorithm which will assist us in constructing the tree. Let us also have a sample in-order array to test our algorithm. We call the build tree function with in-order array. 0 for start and length of in-order array -1 for end. Since start is not greater than end, we find index of maximum element from the array. So we call the max function with the array start and end. Now we have to find the maximum element and its index from array. So we set max to the first element of the array and the max int variable to start. Now we enter the for loop and iterate through the array and find the maximum element in the array and its index. Since in our array we have 40 as the max element and its index is 2, we set max to 40 and max int variable to 2. We return 2, which is max int to build tree function. So in the build tree function, I will be equal to 2. Now we make the max number which is at index I to root. So root will point to 40. We check if there is only one element in the array. As it is false, we construct the left and right subtree using the in-order array. So we call the build tree function with I-1 for the left subtree using a call stack. So now start will be 0 and end will be 1. Again, we call the max function with start index 0 and end index 1. So only the first two elements in the array will be compared and the index of the larger of the two will be returned. As 10 is greater than 5, so the index of 10, which is 1, will be returned. Hence, I will be equal to 1. Now, we make root as the element at index 1. So, root will point to 10. Since start is not equal to end, we call the build tree function with I-1. So now end will be 0. Again, I will be equal to the index of the maximum element between start and end position. As both are 0, the element at 0th position will be the max element and hence I will be equal to 0. Also, root will point to 5. As start is equal to end, we return root to the caller function. Hence, roots left for 10 will be 5. Execution for node 10 is resumed and now we call the build tree function with I+1 and end. So start will be equal to 2 and end will be equal to 1. As start is greater than end, we return null. So 10's right child will be null. We finish execution for node 10. Execution for root 40 is resumed. Now we pass I+1 to start and 4 to end. Next, we find the index of the max element between index 3 and 4. So 30 is greater than 28 and hence 3 will be returned to I. Now root will be equal to element at position 3, which is 30. As start is not equal to end, we construct the left subtree of node 30. So we call the build tree function with start as 3 and end as 2. As start is greater than end, we return null. Hence, 30's left child will be null. Now we build the right child for node 30. Hence, we call the build tree function with I plus 1 and end. So, start will be equal to 4 and end will also be equal to 4. As both start and end are same, we return the element at the 4th position. So, 30's right will be 28. Finally, we return root, which is 40. As you can see, we have constructed the final tree from the given Inorder array. Now, let us have a look at the time complexity of the program. This code will run in big O of n square complexity. Here, n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.